Hello everyone, welcome to this tutorial video. Since we already familiar to some of the basic function of other flip-flops, I, Michael James Ambrosio, will going to discuss the T flip-flop in the most simplest way as possible as it could be. So first, we're going to know what is T flip-flop. So the T here means toggle. So the T flip-flop is also known as a toggle flip-flop. This means that the changing the next state output to complement the present state output, it is also a single input version of a JK flip-flop. So here we can see a logic diagram of the T flip-flop. So assuming we don't have this connection, this whole thing is called a JK flip-flop. So by connecting the input J and the input K together, we will have a single input and we labeled it as a toggle input. So this diagram will make it as a T flip-flop. We're going to focus on this truth table for T flip-flop. So we have here the clock, the toggle or the trigger input, and the next state output denoted as the Qn plus 1. So when the clock is 0, the toggle is in don't care state. So the next state output is in present state. So when the clock is 1, the toggle is 0, the next state output is in present state. So when the clock is 1, the toggle is 1, so the next state output is in toggle state. So we're going to focus with these two here, since we can recall that in JK flip-flop, when input J and K has a don't care, the output is in present state Qn. So we already learned that. So we will focus on this one. So we have here the logic circuit diagram of the T flip-flop. So here we will going to input this one when the trigger is 0. We have a 0 here in 0 input. Also here in K input we have a 0 input, assuming that the clock is 1. So here we have 1. Also here we will also assume that the output here is 0, so of course the inverted output is equal to 1. So since the Q prime is the input of our first NAND gate, we also have 1 here. Same goes to this one. When the output here is 0, so it means that the input here in our second NAND gate is also 0. So here, so as we can recall, in the NAND gate, if we have a 0 input, the output is 1. Same goes to this one because we have a 0 input, so this is 1. So here, since the Q prime here is the input of our third NAND gate, we have here 1. Also, we also have an input in our fourth NAND gate, 0 here. So this one goes also here. So we have here 0. So when we have 2 1 in a NAND gate, the output is 0. So here, since we have a 0 input, the NAND gate output is 1. So 1. So it means same. So since we already satisfy this condition, which is when the t is 0, the next state output is in no change condition. So we're going to try this one when the toggle is in high state. So here we have a logic diagram. So when the t is 1, we have here 1, also here 1. The clock is 1, 1, 1. So assuming that the Q here is 0, so the inverted output is 1. So the output here is 1. So the 1 here is our next state output. So this is the toggle process begin. So when the output is 0, the next state output is 1. Same as goes when 1 is the output, our next state output will be 0. So we already satisfy the truth table for the flip-flop. So here we have its characteristic table of the flip-flop. So when t is 0, so we have here 0, same as this, and we will have 1. So when the t is 1, our next state output will be inverted of output here. So we have here 1 and we have here 0. This is the logic equivalent of the flip-flop. However, we somehow modify this by adding the P set and the clear. So let's try to on this. So let's put P set to 1 and clear to 1 also. So as you can see, the Q output is blinking and the Q prime is also blinking. The asynchronous is inactive. When the clear is 1, and let's set the P set to 0, here as you can see, the Q output is steady and the Q prime is blinking. When clear is 0 and P set is 1, the independent of the condition, the clock input has no effect. So let's try putting both P set and clear to 0. As you can see, we get an obscure response. So as you can see, the both input Q and Q prime is not blinking, which is not right because Q prime should be the inverted value of the output Q. That's all. Thank you.